In this week's space startup news, VAST and the exploration company signed a cargo service agreement. In an exciting development for commercial space stations in low Earth orbit, the exploration company's cargo vehicle called NYX, that's NYX, will ferry supplies to VAST's second space station called Haven 2 in 2028. Their first space station called Haven 1 is scheduled for launch in August 2025. VAST, an American-based commercial space station operator, and the exploration company, a French and German space startup. It's worth noting that this agreement is not for Haven 1, VAST's first space station. Due to its single docking port limitation, Haven 1 cannot support separate cargo missions. This docking port is reserved for a Crew Dragon vehicle, which is essential for transporting crew to and from the space station. The exploration company's NYX cargo vehicle can send approximately 4,000 kilos, that's about 8,800 pounds, to Haven 2, VAST's second space station. NYX will be able to return upwards of 2,600 kilos of payload, about 5,700 pounds, from the space station back to Earth. The CEO of VAST, Max Haut, said, "VAST is excited to partner with the exploration company as we strengthen our collaboration with European industry and enable human space exploration with the ESA member space agencies such as DLR, the German Space Agency. We are building strong ties with the European space ecosystem, and NYX is an excellent solution for our space station cargo needs." The CEO and founder of the exploration company, Helen Huey, had this to say, "We are grateful for the trust VAST is placing in our NYX cargo system. We are excited to support future Haven commercial space station operations as VAST feels a replacement for the International Space Station before the end of the decade." Are you excited about humanity finally returning to the moon? Well, we have some progress to report from Axiom, NASA, and SpaceX. Axiom tests its lunar exploration suit. Peggy Whitson from Axiom and Douglas Wheelock from NASA recently suited up in Axiom's new spacesuit designed for use on the lunar surface. The demonstration took place at SpaceX's Hawthorne facility, inside a mock-up of Starship interior. This was an integration test to help SpaceX, NASA, and Axiom understand how the various systems work together. It was a pressurized simulation, the first of its kind since the Apollo era. This was a significant milestone to collect information on how the spacesuit, the lander, and the human element will work together during the Artemis 3 mission. In less than 2 years, Axiom Space has made substantial progress in suit design and testing. The suit design is beyond the preliminary design review point with NASA and will enter the critical design review phase later this year. Russell Ralston, the Vice President of the Extravehicular Activity at Axiom Space, had this to say, "We've conducted many tests with different people, including engineers and astronauts, to ensure the suit's advanced capabilities will enable a wide range of crew members to conduct extensive science research during the Artemis 3 mission to the lunar South Pole." Don't forget to subscribe to this channel to keep up to date with all the space startup news. The next milestone for the lunar suit will be when an Axiom Space astronaut wears it to take the first run in NASA's Neutral Buoyancy Laboratory. We'll be sure to cover it when it happens. In our next news segment, we introduce a company you may not have heard of yet. They are building a powerful new engine and have some progress to share with us. Stoke Space completes hot fire test with its new engine. Stoke Space is currently developing a cutting-edge reusable launch vehicle aimed at providing low-cost transportation to and from space. On the 11th of June 2024, the company successfully completed the first hot fire test for its new full-flow staged combustion rocket engine. The engine will power the first stage of Nova, the company's fully reusable medium-lift launch vehicle. Reaching this technical milestone represents a major leap forward for Stoke, as it keeps the company on track to deliver a commercially competitive, rapidly reusable medium-lift rocket. During the test, the engine successfully ramped up to its target starting power, going from rest to producing the equivalent of 350,000 horsepower in less than 1 second, before holding the power level and shutting down. The engine is designed to produce over 100,000 pounds of thrust at full power. The full-flow staged combustion engine has long been considered the pinnacle of rocket propulsion technology because of its unmatched efficiency and performance. This engine will enable Stoke's reusable vehicle to perform missions to and from a wide variety of orbital destinations while still operating within margins needed for long service life. Andy Lapser, the CEO of Stoke Space, said, "We are incredibly proud of this achievement. Our team has worked tirelessly to bring this engine to life in record time. This successful test is a testament to their talent and dedication, and it puts us one big step closer to bringing the Nova launch vehicle to market. Over the remainder of 2024, Stoke expects to mature its engine and vehicle design while scaling operations for orbital launch. Finally, in this news roundup, a scrappy aerospace company from South Korea is working on a space launch vehicle. Let's find out about them and their new vehicle. Innospace completes a tethered flight test. Innospace is an aerospace company headquartered in South Korea. They are developing hybrid rocket-powered smallsat launchers to provide low-cost, eco-friendly, and reliable launch services to the smallsat market. This week they performed a tethered flight test of the reusable launch vehicle demonstrator. They achieved the primary objective of the test by verifying the performance of the attitude and position control systems at low altitude. The vehicle was powered by a hybrid rocket engine at the Guzman Hot Fire Test Facility in South Korea. Test results of the reusable launch vehicle demonstrator. They reached the targeted altitude of 3.5 meters. Altitude control errors within 0.1 meter, maximum speed of 1.5 meters per second, and attitude control errors in pitch and yaw within 0.6 degrees. Many more upcoming tests will be needed to improve the control algorithms to ensure reliable operation. We'll keep you up to date with their progress. To keep up to date with all the developing news in the space startup scene, subscribe to this channel. Click the notification bell so you don't miss any videos.